Good afternoon. Welcome. I want you to picture this. You have a brilliant idea, one that can potentially transform the way your team or the entire organization operates. It will definitely transform your career. You feel excited, you've got the momentum, you put the plan together, you got the list of stakeholders, you're ready to run with it, you call the meeting with your leadership team, you pitch the idea. The excitement in the room is palpable. And then you get a question. Yeah, but how are we going to fund this? We are out of the budget this year. Or maybe somebody says, nah, we tried this last year. It just doesn't work here like that. Or maybe somebody says, great idea, but, our roadmap is locked for the next 12 months. Does that sound familiar to anyone? Could you please raise your hand? Thank you. Thanks for working with me here. Right. So for those of you who've been there, you know that real innovation can sometimes feel like, let's say, a race with obstacles, where the biggest hurdle is actually the red tape. Today, we will share how to set up foundations for continuous innovation and experimentation in your organizations. You will hear directly from Formula One about their innovation journey and recent technological breakthroughs. With that, I got the stage, I got the microphone. A phrase I wanted to say for a while. It's a lights out, and away we go.
The future is coming fast. F1 drives its data with AWS to generate performance, generate statistical insights, generate excitement, generate a whole new era of fan experience. Now, with generative AI, lights out. Time to accelerate.
I would like to begin with a simple but powerful question. What does it take to make innovation a continuous process instead of a one-off event? When Formula One and AWS first joined forces in 2018, our primary focus was on accelerating F1's journey into the cloud. We were preparing the foundations for the next wave of technological innovation. Fast forward to 2022, we have renewed our partnership, and this time with two very bold and aspirational goals. First, we wanted to bring in that new era of innovation and digital transformation into the entire sport. And second, we wanted to create a blueprint for continuous innovation and experimentation that other organizations, both large and small, can emulate. Over the past 24 months, our teams have been fueling F1's high-performance operations, and they were also transforming the way fans engage with the sport. Later in the sessions, we will be sharing some of the solutions that we have developed together. You can also imagine that delivering on this, let's say, quite bold vision requires careful preparation before any work even begins. So to make this innovation continuous for both of our companies, we aligned on the following core priorities. First of all, we wanted to embrace the failure. We know that if we are experimenting truly, failure is inevitable. But each failure gives us a new data point, a new insight that takes us closer to the next breakthrough. And so the key point here for us was to ensure that this learning cycle is not left to chance. We needed mechanisms that allow this process to be repeatable and scalable. Then, we wanted to empower our teams to act decisively. We wanted to unlock their creativity and speed across both organizations. Having two organizations in this mix makes things more challenging. And lastly, our bold goal was to create experimentation velocity. We wanted faster iterations to get insights faster, then feed into our ideas so that we can get to the right solution sooner. Every team, every organization, every partnership will need to figure out what is the right mix of these priorities. Think of this as a recipe, right? The right proportion will depend on your risk appetite, on the size of the team, on the type of problem that you're trying to solve. However, the speed of experimentation was not our sole focus. When we talk about doubling the number of experiments to double our inventiveness, it's also not just about the volume. It's about intent and execution. We do frequently observe customers shy away from high volume of experiments. And when we ask business and technology leaders what the reasons for that, we frequently hear two main reasons. First is taking the focus away from the core product and concerns around that. And the second is actually the cost of experimentation could potentially get out of control. In our collaboration with Formula One, we have proved the following hypothesis correct. The cost of experiments is actually low, and it only gets expensive if that succeeds. And I would say, arguably as a business, this is a very good problem to have on our hands. When we think about experiments, we want to scope them to be fast, actionable. And we also want to empower the experimenting team to actually execute on these insights and experiments that they conduct. At the same time, continuous innovation cannot rely solely on extraordinary individuals. We need them, but they are not the foundation. We need to have mechanisms that allow us to scale beyond individual effort. In our partnership with Formula One, to ensure that all ideas receive the right amount of attention, we created what we called an innovation framework. We use this framework to generate ideas, capture ideas, iterate on ideas, choose which ideas we want to build. But what we've also done is we created a mechanism to stop bad ideas from going forward. Can I see any hands if your team or your organization has an effective mechanism to prevent bad ideas from developing? Thank you. Still, thank you for working with me. That would be awkward. Right, and I think this is normal. For those of you who can't see the room, actually, I don't think I've seen a single hand. As individuals, we don't like to admit that, my idea is not good, my idea is not the right fit, the timing is not right. But having a mechanism to deal with this takes the personal element out of this process. With Formula One, our imperative was basically aligning any initiative on two axes. First, does this align to one of the 6 core strategic priorities for Formula One? And do we have a business sponsor identified? If the answer to any of these questions was no, we moved on to the next idea. At the core of this innovation framework is Amazonian working backwards approach. It's a process and methodology that we use internally at Amazon to launch all of our customer-facing products. In this mechanism, we create a fictional press release and frequently ask questions. In this press release, we imagine a time in the future where we have already launched the product or the solution, and from that point in the future to us today, we describe how do we announce the launch, what do customers say, how does the customer experience look like. Having a single written narrative allows us to gather feedback on the initiative early on, iterate, align resources, and get ready to run when we are ready to do that. It is the same mechanism that we use to prevent bad ideas from going forward. Having ideas is great, but it's not enough. We need organizational systems that allows teams to act effectively and efficiently. There is no one-size-fits-all. Unfortunately, I can't give you the right answer to this. For example, at Amazon, you might have heard we are organized in what we call 2 pizza teams, small, nimble teams, autonomous decision-making. What it creates for us is the reduced time spent on communication between the teams. We have more time to think big, and we have more capacity to experiment. That allows us to drive that velocity that we are aiming for. In our partnership with Formula One, we structured our efforts around cross-organizational core team, 8 to 10 people. Every team member in this core team had very well-defined roles, responsibility, accountability. We did have the RACI framework, and we worked quite a long time on that. What's also important that this core team was empowered to make all daily operational decisions to keep initiatives moving without relying on any additional approval cycles. What Formula One have also done, they dedicated a small annual budget specifically for this team to fund prototypes and proofs of concept outside of existing budgeting cycles. Having the structured choices allowed us to reduce organizational inertia and reduce delays. I'd like to draw your attention here. We're actually not trying to eliminate delays. We're trying to reduce them. Structural autonomy alone is also not enough. We need disciplined approach to decision-making, right? How do we make decisions? Who is making decisions? Single-threaded ownership allows one business leader to have a full-time job, to think how to solve the problem that we are trying to solve. It is their responsibility to drive progress, to align resources, to remove any obstacles on the way. This single-threaded ownership model reduces inefficiencies that come from a shared ownership model. With Formula One, we actually initially started with a steering committee as a governance model. But soon enough, we realized that we're actually moving too slow for the type of decisions that we need to make daily. And so we moved to single-threaded ownership. And again, as a result, greater speed, fewer dependencies, we couldn't eliminate them, and also a structure that allowed to kind of push every initiative through the pipeline, right, through every stage of the innovation framework. But not all decisions are made equal. We at Amazon have a concept, you can see it on the screen, one-way or two-way door decisions. And this concept allows us to balance speed and quality of decisions. What that means? A one-way door decision is the type of decision that has high or costly or expensive consequences, right? It's hard to reverse. So you go through the door, it locks behind you. What we want to do, we want to spend more time and effort on this type of initiatives before we decide to proceed. On the other hand, majority of the decisions that we actually make in our professional, maybe even personal life, are actually two-way door decisions. It's the type of decisions where you can reverse the outcome if you don't like it. You go through the door, you see what's there, you like it, you continue, try another door. If you don't like it, you come back, try another door. What we've also learned here is to act fast. So we proceed when we have 70% of information we wish we had. If we are waiting to have 80% of information or 90%, it's nice, but it's slow. It probably means we are moving too slow. And what we know is that we can't be late and innovative at the same time. So speed is critical for us. At the same time, we don't want to experiment for the sake of experimentation. Right? We also don't want to run fast, but without purpose, without direction. Innovation is not a purpose on its own. It's the impact that innovation creates that we want to see. With Formula One, every experiment, every decision, every mechanism that we developed only served one purpose: make impact where it mattered the most. And what helped us is actually F1's clarity of whether they want to create the impact. They were focusing on two things: making smarter, faster decisions on the track, and creating deeper, more engaging experiences for their fans. Right? So we were all about turning that innovation into outcomes. We were challenging every initiative. Is this the outcome? Is this the impact that we are aiming for? And turning that innovation into impact is exactly what we have done. I'm now honored to invite David King from Formula One to share F1's innovation journey and his experience working with us. David, welcome.
Thank you very much, Olga, and thank you all for coming. Thank you for the round of applause. You should have saved that. Before I introduce Formula One, give you a bit of background about what we're all about and some of the steps we've taken on our innovation journey, I want to take just a very short minute to pay tribute to this man. Not many of you will have known him, but he's very important to F1. He was a loving husband, father, brother, and colleague, but he was also instrumental to the innovation relationship we're talking about here today. Pete was passionate about everything F1 and technology, and he instilled that passion in everyone at F1. So we wouldn't be on this journey if it wasn't for Pete. So what is F1? I imagine some of you are fans, and it's kind of hard to avoid the remnants of Vegas and the F1 event when you're at reInvent. Many of you watched on TV. Perhaps you've been to an event. So in 2024, we have a 24-race season. 1.5 billion people will have eyes on glass watching some kind of F1 content. And in the Americas, we've actually got 6 races this year, 4 in North America, and then down into Mexico, still technically North America, and Brazil. 6 million people turning up and enjoying our content and enjoying the racing. And that's one of our primary focuses, and I'll keep coming back to the fans. It's everything we do. Forward. So, 3 key parts of our mission: creating a truly global spectacle. We are privileged to be the rights holder for the Formula One World Championship, which means we get to put on 24 events around the world every year and share that with the world. This season, as I say, 24 events. That was 5 continents, 21 countries, 5 double headers, that's back-to-back race weekends, and 3 triple headers, back to back to back. It's a really challenging schedule for our team, and that's important when it comes to talk about innovation, the size and shape of that team. We strive to really create a really positive and inclusive environment, not only within F1, but within motorsport. So 2 years ago, we launched F1 Academy, a female-only racing series. In Abu Dhabi this coming weekend, we wave the checkered flag on the end of that 2nd season, where it looks to develop not just drivers, but engineers, female team principals, to take their careers to the next level. Sustainability, really key part of what we do, and actually something that we needed to address. We've set ourselves a target of being net zero by 2030, and the way we've tackled that involved some innovation along the way. We've moved a lot from sea freight or from air freight to sea freight. Where we can't, we're using sustainable aviation fuels. And we've also implemented a remote operations model. Remote operations means that historically, we used to send loads of people and loads of infrastructure to the circuit. We created a program, time the whole event, everything happened at the circuit, and it was then shared with the world. COVID accelerated some plans we had to move to a remote operations model. That means we take less kit and fewer people to each event, cutting down our carbon footprint with a fixed location back in the UK. The last bit, and we did this talk yesterday, we're talking about F1 being at the cutting edge of technology. We're a 75-year-old sport, but we continue to be at the cutting edge. Everything from our on-car system, gathering all the telemetry we're going to show you later on, all the positioning data, all the video feeds that we take off the car, to a remote operation setup, which is one of a kind, to use of AR graphics in production, overlaying all of that telemetry data live onboard cameras showing how close the drivers really are, trying to bring that experience to the fans. Some of the challenges we have. We're a lean team. We're not thousands of people. We're 600 to 700 people across all aspects of F1, right from legal, commercial, marketing, digital, live production teams, content creation teams, social media, everything that goes around creating an F1 event and sharing it with the world happens within that team. The sport is more and more data-driven. For anyone who's been a fan of F1 for a long time, you can see that the drivers now trying to find that every 10th of a second to win and get in front and be in pole position after qualifying. We as F1 have to try and keep up with that and at times be ahead of that so that we can really demonstrate what's happening in the sport. But we recognize that there is a barrier to entry into F1. If you're not a motorsport enthusiast, actually turning up and watching the content, the terminology that's used, DRS, undercut, can be quite challenging to understand, and it can take away from the viewing experience. So some of the things we're doing to make it more accessible to the fans. The last bit around diverse working environments, it's probably easier to explain with an example. Back in 2019, we were set up for a race in Japan, in Suzuka. Everything was great. And then we get a typhoon warning mid-weekend. Now, we take about 7 days in advance of a race weekend to set up our infrastructure around the circuit, camera positions, timing loops, all the hardware that we need to run a race, and it's set up inside an event technical center. Within 24 hours, our team completely deconstructed all of that infrastructure and moved inside the pit buildings where it would be safe from the typhoon, but didn't just move it and set it there, completely reconfigured it so that we could turn up and have a race on Sunday and continue with the schedule. So the team really do have to deal with some interesting and challenging situations. Big bets. Bit cheesy. This is kind of where our AWS partnership comes into play and what's really relevant for innovation. Olga touched on it, and that it doesn't necessarily have to be a bad idea to be discarded, but if it's not targeting one of your key initiatives, it's not pushing the right buttons, then for now, you park it and you move on. So these are the 3 areas that we work across in F1. So high-performing operations. As I said, it's challenging shipping kit around the world to 24 events a year and making sure everything runs smoothly every time. Some of this infrastructure gets set up, taken down, and moved to every race. Some of it is fixed. But we're also trying to support mission-critical applications. Some of those sit across lots of different locations, and we can't turn up to a race on a Sunday and not be able to time the event. In fact, the event would be cancelled. We as F1 have to provide that timing system to the FIA in order for a race to go ahead. World-class racing. Anyone who follows the sport will know back in 2022, should have been 2021, we introduced a new set of car regulations. What we were trying to do was promote closer racing, more overtaking, more excitement. The way we did that was actually using computational fluid dynamics, CFD, high-performance computing to do lots and lots of simulations of a concept car. We actually have one that's built and sat in the office. There's no engine in it, unfortunately. But we used that high-performance computing to do that, and actually the results we saw were closer racing, more overtaking. Desired result. Fan experience. Ultimately, it's all about the fans. But the barrier to entry is there. So we've worked with AWS, we've generated F1 insights. So if you watch a broadcast, you will see someone is gaining. We think they can overtake within 5 laps, given the rate they're gaining at. If Max pits now, then there's a threat that Lando will undercut him when he pits the next time around. Predicted qualifying times. trying to show people what the drivers could achieve. We use all the historical data to drive that and say, actually, we think, not Mercedes or sandbagging, but we think that they could go faster. We think that by the time they've got through Q3 and they've laid down lots of rubber, that actually this will be the time that will be the pole sitter. We launched our helmet camera in 2021. Gives the viewer a unique position in the car. You actually get to look out from the driver's eye and see what they see, and it is awesome. It looks fantastic under the lights, down the strip in Vegas. Helmet cam is awesome. So I've probably talked enough, but I'm going to talk about one innovation and then show you a video. This is Track Pulse. So this is one of the innovations that's gone through the process that Olga described at the start. F1 is complex. We're talking about 20 cars and drivers spread over a 7-kilometer circuit. We have lots of camera positions, and that's great, and we can cover it well. But it's not a stadium sport with one ball, where it's quite easy to follow, see who's got it, and what's going to happen next. What we quite often find is that our production team do a fantastic job of telling the story of every session, be it a practice session, be it a qualifying session, or be it the race. But quite often, what gets missed are mid and lower order battles, things that actually people are interested in, because not everyone is a fan of the team that's at the top. And what we were trying to do with Track Pulse was take all of the telemetry and positioning data that we gather as F1, combine it with our historical data, and so we use a combination of ECS and an MLP story machine to process that data and drive out all the stories of the race. Not just that Max has pulled away from Lando by an extra 1/10 of a second on the last lap, but actually that Yuki has gained half a second in the last lap. And if he continues at that rate, he is going to be in position to take 9th. And what does that mean for the Constructors' Championship? So we tried to build a tool that could be used by our production team, our broadcast partners, and our commentators to tell the story of the race better. So this is Track Pulse.
24 circuits across 21 countries. 20 drivers all out on track, chasing one dream. Formula One brings the action to millions of passionate fans, telling authentic and engaging stories that unfold on the circuit through global production. AWS partners with Formula One to drive technical innovations all the way from pre-season testing to the final race in Abu Dhabi. Just like drivers and their teams, the F1 production broadcast team makes split-second decisions across various data sources to ensure fans around the world don't miss a moment of the action. Real-time access to data is everything. With up to 300 sensors on every car, over 1.1 million telemetry data points are generated every second. Together, AWS and F1 have developed Track Pulse, a single view making it easy for the live production team to identify every story as it unfolds. Track Pulse combines real-time action with historical data to deliver engaging insights to the fans at race pace. Track Pulse, powered by AWS.
Should have let the audio finish on that. Sorry. I'm going to bring Gaurav onto the stage now. He's going to talk a little bit about the culture of experimentation and one of our other innovations. Gaurav.
Thanks, David. Okay, folks, my name is Gaurav Kaila, and I lead a team of engineers that help customers like Formula One innovate on AWS and build solutions like Track Pulse. You've heard Olga speak about some of the innovation mechanisms, and I'll build on top of that by talking about another mechanism that we call culture of experimentation. In this part of the presentation, we'll hear how Formula One has nurtured that culture of experimentation. We'll talk about a real-life business problem that we have solved together with Formula One using this culture of experimentation. And finally, which is the best part, we'll leave you with some best practices to incorporate the same culture in your own day-to-day work. But before we talk about culture of experimentation, let's understand what experimentation is and what is an experiment. Innovation has and will continue to be the center stone to transform industries. And for me, innovation is like an onion with multiple layers of defining what it truly means. Behind innovation is technology, powering some of the biggest breakthroughs. Behind technology is an often overlooked practice of experimentation, a practice involving a series of small steps, hypothesis testing, trial and error. But you might ask, Gaurav, what is an experiment? Given everybody's talking about generative AI, we'll talk about the same. I posed this question to 3 commonly used large language models and asked them, what do you think is an experiment? And this is what they came up with. Luckily for me, they were very similar. You start to get the attributes of what an experiment is. It is a process, it's an exercise which is conducted to prove something, to prove a hypothesis by giving evidence. But there's one factor, one attribute that all 3 definitions miss out, and that's time frame. An attribute which is extremely critical as we talk about experimentation in an industrial setting. While you might have 5 years or more to prove out a hypothesis in an academic setting while you're doing your PhD, it's highly unlikely you'll have the same time frame to do when you're proving a hypothesis in an industrial setting. Let's look at how time frame features when you're talking about experiment-driven innovation. Most customers, most companies approach innovation linearly. They start with an objective, they set a goal, and they march towards it directly. You can start to imagine there are certain issues with this approach. First, if the problem is too complex, it's too large, enthusiasm begins to wane as the exercise goes along, and it fails. Worse, which happens quite a bit, is new stakeholders join in, priorities change, and again, the exercise begins to fail as well, not hitting the mark. Experiment-driven innovation takes a different look at it. First, to understand what is the baseline. What's the current state of the problem you're trying to solve? And taking small steps to get to that baseline. Next is to take small steps, that series of trial and error, to get to the goal that you want to meet. Not each experiment, not each step is going to get you where you require it to be. There are going to be failures, and that's absolutely fine. Olga spoke about embracing failures, and that's exactly it. Embrace failures, learn from it, and go to the next step by embracing those failures. It's intentional that the point doesn't land to where the goal line is, because as we go through these experiments, you need to pivot. You need to pivot to something which is important, which can bring you that value as you take the next step to go towards that goal. This is not just AWS, us saying it, or Formula 1 saying it. This is backed by data. McKinsey estimates that 70% of businesses fail to transform because of lack of innovation, or more importantly, methodology or framework to implement that innovation. And the mechanisms Olga spoke about, and a culture of experimentation, taking the series of small steps, is the right framework, we believe, to get you driving innovation within your own organization. I'm going to stop talking here because I know you're here to listen to Formula 1 and not me. So I'm going to bring David back into the conversation. And David, tell us, what does experimentation look like within Formula 1?
I mean, this quote is pretty apt, and I mentioned it earlier that in 2025, Formula 1 will be 75 years old. So if we hadn't been innovating across that time, we just wouldn't exist as a sport with the fan base that we have and continuing to grow. The number of innovations that have come out of F1, not necessarily our organization, but the sport as a whole, that you will have used perhaps without realizing it, pretty numerous. So I'm going to give you some examples. Regenerative braking, hybrid engines, disc brakes, carbon neutral fuels, all things that came from Formula 1 first and then made it out into the real world. One of the more kind of notable innovations actually came way back in the mid-80s when we put the first onboard camera onto a car and broadcast it live during a race. It's not a mean feat to send live moving pictures from a car traveling at 230 miles per hour down the Las Vegas Strip. But we did it. We had to innovate. We took small steps, and we got there. The next kind of major innovation in onboard camera technology came in 2021 with helmet cam. We could see that there was a unique perspective to be given to the viewer by having a camera in the driver's helmet. But we could have shied away from the challenge because actually interfering with what is essentially a safety device and protecting the driver could have been a step too far. But we pushed through. We worked closely with FIA and the helmet manufacturers to make sure that we could bring that view to the viewer. And I think anyone, hopefully, who has watched some content will agree that it looks awesome. Innovation is really important in any organization, but going about it in the right way. Now, the way that Olga described that we have set up our innovation framework works for us. That doesn't mean it will work for your organization. It has to be you to decide what's your tolerance to risk before you can actually get the velocity that you want to get. We didn't get it right first. Olga said we started with the Steerco model. It was too slow, it was prohibitive, and we weren't getting the level of innovation that we expected.
Thanks, David. As you're preparing through this presentation, there's a lot of innovations that, as a Formula One fan like me, didn't realize that Formula One was the first company to do that. And so it's really interesting as we build through this presentation. Now, let's look at a real-life example of this culture of experimentation and innovation in practice. Together with Formula One, we collaborated to solve a problem for F1 engineers, a problem so critical for F1 engineers that it impacts them nearly every race day. Through this example, again, you can try mapping back to some of the mechanisms we spoke about, namely working backwards, the PRFAQ document, experimentation, and scaling that experimentation. But before we give you what we built, it's extremely critical to understand the vast IT infrastructure of Formula One. So again, David, can you explain us what IT infrastructure within Formula One look like?
I'll do my best. The picture that you can see here would have looked very, very different about 5 or 6 years ago. The first step, and Olga explained this, the first kind of iteration of our AWS journey was moving things into the cloud. So that's where the cloud bit comes from. The more significant bit since then, and where this particular innovation comes into play, revolves around our traveling infrastructure. And I mentioned our remote operations model. So if we look at the picture, what we have at Circuit are lots of equipment that captures video data, telemetry, and positioning data from the cars, processes it, and makes it available for all of our graphics platforms, the classification documents that we produce for the FIA. And as I said before, all of that historically used to sit entirely at the circuit. It was a self-functioning unit. We split that in two. So we have a smaller version of that now that goes to each circuit with infrastructure that runs where latency is really important, because some of the circuits are quite far away. Some of them are in Melbourne, for example, and the return time is not great. We have that infrastructure at the circuit. We now have a fixed location in the UK with a full production setup and with lots of our software engineers and IT support engineers sitting there as well. That means we send fewer people to the circuit, less infrastructure. And whilst it added benefits in terms of sustainability, it introduced some technical challenges, because now we're supporting applications not just running in the cloud, running on physical infrastructure at our base in the UK, but also running at each circuit. The other major challenge with this is actually that end-to-end picture exists for an entirety of about 5 days before it gets torn down again after the race. The track element gets packed up and it gets shipped to the next event. So when it comes to supporting applications that are mission critical from our perspective through a race weekend, triaging, adding new features, because we need to do that as well, and actually getting to the bottom of a problem within a race weekend, given that those 5 days, 3 of those days we have cars on track. And we shouldn't really be tinkering with things when we have cars on track. So the window of opportunity is tiny. So we needed a way to capture, triage, and diagnose and resolve those issues efficiently, and that's where RCA comes in.
Yeah, thanks, David. Absolutely love that, right? Being a Formula One fan, it's always about the glamour, also it's about people on the track, but never about the IT infrastructure that actually backs all of that. So it's really interesting to hear that. Okay, now let me throw some numbers at you, right? David already described the vast infrastructure that Formula One has. Formula One hosts about 18 petabytes of data on S3. It has about 375 EC2 instances, about 180 RDS instances across 100 plus AWS environments. That's a lot of systems being managed. It has about 180 applications managed by different teams and different systems. So if during race day, an F1 engineer needs to figure out why a database they cannot access a database, they estimate it takes them about 15 to 30 minutes just to figure out if a database driver is supported. It takes them up to 2 hours to query the relevant logs. Now, you can imagine this is critical time being lost when the race itself is a maximum of 2 hours. So if an F1 engineer is focusing their time debugging stuff, by the time the race is already over. For critical events that averages 1 per race day, F1 estimates that takes them up to 3 weeks of engineering time to figure out first what happened and then to fix that issue, because they're working through different teams, including development, operations, networking, and infrastructure. Recognizing this challenge as an opportunity to innovate, we collaborated with Formula One to build what we see on the screen. We call it the RCA chatbot, the root cause analysis chatbot, which is nothing but an assistant that we have given to F1 engineers to help augment their process of debugging. The goal in this was to create a solution that any engineer can use, despite their level of experience, their level of tenure in the company, to understand what is going wrong and hopefully fix the issue. Reflecting back on certain principles that Olga spoke about, first it was important to understand what sort of business problem are we trying to solve, right? What are we trying to get towards? Once we got towards that, we wrote a PRFAQ document, got all stakeholders involved, got their approval before we put hands on keyboard. That hands on keyboard was a 5-week experimentation exercise through which we did a lot of trial and error, a lot of hypothesis testing to produce what you'll see in the next slide. Not each step of ours was successful, and it's absolutely fine. It was good to learn through this exercise before we proceed to the next step. This is the demo of chatbot in action. I'll play the video. It's fairly self-explanatory, but once the video completes, I'll also walk through the steps of the video on the steps of the solution.
One we're going to do is a database troubleshooting one, and this is sort of based off of an example that Martina's highlighted that happened during a race weekend. So the first question I'm going to ask is, copy and paste. So I can't connect to a SQL database. I think it's my driver that's the issue. Can you tell me if this particular driver is supported to the chatbot up here? So it's come back and told me that yes, actually that this driver is supported according to the information that it has. So the next question will be, can you check the networking? I'm connecting, I might not know what IP address, but I know I'm coming from an IP in this range. I'm connecting to the US West 2 AWS region, and I'm connecting to an EC2 instance with this ID, and I'm trying to connect to port 1433. The chatbot's able to then go and query and see if I would have access. So it's come back and said, based on the network access check it's done, I should have connectivity within that range, and the instance is running and accessible from my network. The chatbot that. Can you tell me the health status of the database instance, please? So it's come back and said that the CPU usage is low, has free memory available, there's no database locks, and there are no heavy or top SQL consumers being reported. And so combining all of those metrics, it's then determined that actually the database does appear to be in a healthy state. And finally, say I've run through all those steps and all of that's okay and I'm still lost, I might now want to escalate this to someone else, and I might want to raise a JIRA ticket to achieve that. Based on our conversation so far, please raise a JIRA ticket about this issue containing a summary of checks we have done. See there, it's come back that the JIRA ticket has been raised successfully, it's provided the summary, and the ticket's been logged for further investigation. So if I go over to our JIRA board, this is just like a sample JIRA board for now, but we can see that a new one's been raised and able to connect to a SQL Server database. It's provided a summary and some of the steps that we've tried, and some information for this to then be escalated further.
Okay, Now, what you saw the F1 engineers solve in this, or try to solve in this, was an actual issue that happened in one of the races, right? So you can imagine the F1 engineer walking through these steps manually if they didn't have this assistant. So, and they did the same thing with the assistant. First, figuring out if the health of the database is correct, figuring out if the networking works for this particular database or not, and then figuring out if the database driver is supported. Rather than having to know what APIs to call themselves, the agent replaces that. The agent goes out, it's connected to the right systems, connected to your CloudWatch logs, figures out if something is going wrong, and reports back to you. The best part, and this is what we realized was the biggest amount of benefit for F1 engineers, it logs all of that into a Jira ticket, if it cannot solve the issue, of course, and then escalates it to the right team. So when the team picks up this ticket, they do not have to repeat these exact steps because they've already been tested out. So it reduces the time of issue resolution significantly for not only the F1 engineer on the race day, but also any escalation teams this goes to. Again, repeating the fact, it's critical to understand that this is an agent that can be used by any F1 engineer with any sort of skills, any sort of tenure in the company. Now, this is a technology solution, right? Each technology solution needs to be backed up by business outcomes. So David, could you help us understand what the business outcomes of the solution was?
Sure. So first and foremost, and Gaurav hit it in the head, but this is the actual number, we were looking at, or we set out to reduce the resolution time on common issues by a significant margin. I think 86% is pretty significant. So it's definitely giving the engineers time back. What the demo showed, though, is an engineer querying the chatbot, asking what were relatively technical questions. But actually, the people using those 180 different applications aren't necessarily support engineers, developers. They could be a graphics operator who is trying to find out why they can't get the positioning data, or why the left-hand side bar that you see on the screen, if you watch some content, is not loading. So the chatbot gives them the ability, regardless of their skill set or their knowledge, their technical knowledge of the system, to say, this thing isn't working. Please, can you help me figure out why? And when it can't, the data consolidation piece comes into play. Because as part of doing this and making the chatbot accessible, we've had to pull all of our data. We've had to go and make sure we've got access to it. So when it can't solve the problem, it makes the next step of the triage much easier. So the person who was going to pick up that Jira ticket didn't need to go fishing for the logs on that SQL server, because it'll have been referenced inside the Jira ticket. It cut down the next step. So we didn't solve that problem, but we can solve it much quicker because we've got immediate access. And it allows us to escalate to the relevant teams, because it can determine, based on the questions and answers, whether it's a thing that our network team needs to look at, or whether it needs to go back to our software development team, or someone else entirely. And again, that end user, who isn't necessarily technically skilled, doesn't need to make that decision and think, okay, well, this feels like a network problem. So we've taken some really good steps, and we've used a small sample set of problems. It's given us enough confidence to take the next step and onboard more applications and grow RCA's kind of issue database. The exciting thing beyond that, I think, will be looking at not just fixing problems, but someone turning up and saying, I need access to this. Can you tell me what I need to do? And creating the change. Now, I don't expect it to go fully automated and someone to say, I'd like access to the results database. And for it just to happen, we will almost always keep human in the loop and allow that change to be reviewed. Is that the most optimal way to do it? And we'll continue to improve that way.
Thanks, David. Again, repeating ourselves, all of the work that we do together to do these mechanisms is not to build technology solutions, but rather to achieve the business outcomes that David just spoke about. Now, best part for the last, right? We spoke about a lot of theory, spoke about a lot of practice, but how do you get started, big or small enterprises, in doing the same thing within your own day-to-day work? And I've nicely encapsulated that into a single slide. First and foremost is work backwards. Whatever that looks like in your own organization. Understand the business problem you're trying to solve. Don't understand the technology, understand the business problem you're trying to solve, get in the right stakeholders, write a document. It doesn't have to be a PR FAQ document specifically, but write something down that people can read, feedback, and go from there. For Formula One, it was to replicate what F1 engineers would do on a day-to-day basis. And that was the problem we were trying to solve. Once you established what you're trying to solve, go into a process of experimentation. Take those small steps to get to your final business goal, right? Embrace failure. Failure is good until the time you're actually incorporating those failures into your lessons and into moving forward. And finally, once experiments succeed, and back to Olga's point of experiments, then it starts to pay off, take those experiments, scale them to multiple users, scale them to multiple stakeholders, and try to see what feedback you get. If this works for your team, try to incorporate this culture into other teams as well. Don't keep it in your own team, because you never work just within your own team. You work across multiple teams in your organization. This is just the start of your innovation and experimentation journey, right? This is just a 50, 60-minute session, but there are a lot of other resources available as well. The first one, and I'll keep the slide on for a couple of seconds for you to take a scan of it. The first one is describing the mechanisms that we spoke about in this session in a little more detail. And the second one is talking about a lot more innovations that AWS and Formula One have done together. A particular one that is quite exciting is about creating a trophy for the Canadian Grand Prix using generative AI. If you like what you heard today, right, there are other innovation talks as well that are currently going on. Some of them are already over today, but there's one for tomorrow as well. I do encourage you to go. Some of them are breakout sessions, should be available on YouTube as well, post the conference. This concludes our presentation. Hopefully you've learned some practices. This is a learning conference. Hopefully you learned some practices and mechanisms to deploy innovation and experimentation within your own organization. And I know there are other sessions on in parallel as well, so sincerely thankful to you for spending the last 60 minutes or so with us. If I can make one last request before I let you guys go, is to go into your reInvent application and leave us feedback. We do these presentations on and off. It really helps us improve as we give the next presentation. We'll be in the lobby for the next 15 minutes or so, so if you have any questions, do find us and ask us any questions you have. Thank you so much.